everyone. Now we're working on leetcode 3186, the maximum total damage with spell casting. And this is a very interesting problem. It's a dynamic programming, and but it has a lot of constraints. We need to think it very carefully. So here is the main idea. So we are given an array power, and each time we can decide whether to cast a spell with a damage of power I or not. However, there are some constraints. So once you used power I, of course you cannot use it again, and also you cannot use anything with this value. So from power I -2, -I, and +1 and +2, you cannot use those four values. And you're required to return the maximum possible total damage that the magician can cast. There are two examples, and we can go through them one by one. For this first example, we have the power here, and the output is 6 because we can use 1, 1, and 4, right? Notice that you can use power, although you cannot use this power I, but you can use other power index, even they are with the same value of power I. You just cannot use the same index once again. So you use 1, and you can still use 1 on index 1. And then you cannot use 3 because it equals 1 plus 2. It's this value here. And then you can choose 4. So the way you choose is 1, 1, and 4. So the total is 6. And let's see the example 2. And for this one, you can use 1, and then you can use 6, and then you cannot use 7 because it's 6 plus 1, but you can use the other 6 again. So the total is 1 plus 6 plus 6 equals 13. Okay, and the power length is on the order of 10 to the 5th. So it's pretty large, and we think if we use dynamic programming, we cannot use like n square algorithm. The best we can do is to use like n log n, something like that. So let's do it. So we will define the long is long ll. This will make writing shorter. And we define n as the power size, and we will have two dp two vectors to represent dp state. So they are initialized with min at int min at all its positions. So this represent for fi, it means we don't use power I. The maxed damage can be achieved for range can be achieved with power from 0 to I. Okay, fi is this, and for gi is we use power I, and the maximum damage can be achieved with power from 0 to I. Okay, so then we have the state transition function. It is for f, it's pretty simple. It's just the maximum between I minus 1 and gi minus 1, because we don't use the power at I, so there's no limitation. But for gi, the things are complex. So the one thing is, if gi minus 1 equal to gi, what will happen? Then gi will just be updated by gi minus 1 plus power I, right? So because these power I minus 1 and power I are the same value, so now you are already decided to use power I. So you can use power I minus 1 as well, so that gi is the maximum value will be this one. And the second condition is what will happen if gi minus 1 is, oh, of course, I forgot to mention, we will sort power, right? It's a very natural idea. We will sort those power. So this means all the ones with same value will be next to each other, and the left side will be the lowest power, left side will be the highest power. So in this case, the second condition will just to be gi I minus 1. Oh, this is power. Okay, power. And this is power as well, power. And this is power. It can only be less than power I. Cannot be larger because we have already sorted it. So in this case, things are very complicated. We need to find, in this case, we need to find the valid index where power idx is less than power I minus 2. Okay, we need to find this index because as required, we cannot use anything with those 4 values, and power I minus 1 will be on the left side, so it cannot be greater than power I. So the only requirement is if we want to use some index, it should be less than power I minus 2. Then suppose we have found this index, then gi can be updated. It'll be the max of idx and gi idx plus power I. Okay, yeah, this is the main idea. So then let's implement, write the code. We already have defined f and g, then we need to initialize it. F0 is just 0 because we don't use power 0, and g0 is power 0 because we are going to use power 0, and power and will be greater than 1, so we don't need to check the index. Then we just do the loop, I equals 1, I minus n. Then fi, what is fi? It is the max of this one, right? It is the max of these two. Then we will do for gi. So we first check this condition. If power I minus 1 equals power I, then gi is just gi minus 1 plus power I. Will continue, right? Otherwise, it is this condition. Then things are a little bit complicated, but still okay. We will use binary search to search this one. In order to search this one, we need to either write your own binary search method, or you use lower bound or upper bound. In order to use that, you will actually use upper bound to find the next one after power idx. Then you do a one step back to get power idx. So it is upper bound from power begin to power end, we will search for anything greater than power I minus 3, right? So if this is already the power begin, what does this mean? This means there's nothing we can use, so we just use power I and continue, okay? Otherwise, if the iterator position is not power begin, we can go one step back. So this is value less or equal to power I minus 3. Okay? I'll always say this way, right? Then we can get the index. It is just a distance between power begin and the iterator. Then we can update GI. It's the maximum of this, right? The max of those two plus the current power. And I think we are done, right? Finally, we just return the maximum between G and F. So the maximum between either we use this power or not use this power. Okay, let's run. Yeah, we're very lucky and it's passed. Okay, let's submit. Okay, yeah, and working. And I think that's it for this question. It's a very hard DP, I think, but it's labeled medium. I don't think it's a medium. Okay, and thank you for watching. See you next time.